apply it. And actually, the bonus on the test was applying it. Did you guys notice or recognize the bonus on the test? Wasn't it a limit of a difference quotient? And then didn't that denote a derivative? Does anyone remember off the top of your heads? Because I know you guys, and you remember test questions pretty easily to ask people afterwards. What was going on as far as function that you were supposed to be doing the difference quotient to? Oh, you guys don't remember the function? This is so funny. Maybe I'm not so scared after. Like that? Wasn't there a function beforehand or no? Oh, I just gave you that. It's because I'm smart like that. Anyway, I think it was a 3 and then an x plus h. Wasn't it like that? Are you sure? Was it 3x plus h?
I'm pretty sure it was 3 was outside. Yeah, 3 was outside. It was definitely outside.
Anyway, this is a problem. Yay, go team. And after the end of the day, I don't know if it's the problem, but it's a problem. That's very similar to what I'm pretty sure the test had. What was this supposed to be finding? A derivative. Of who? Of this guy. How do I know? Because this is the definition of the derivative, where you have f of x plus h minus f of x all over h. This is the definition of the derivative, and where was I looking to get the function that I wrote up above? This spot, right here. So in section 2.2, we're going to be able to take a limit like this and be like, oh, you're just a hidden derivative of this guy, and use power rule. Power rule, how does that work? Bring down the 2, it's an 8 times x minus the 3, and the x disappears. 8x minus 3, wasn't that the answer to the bonus? I think it was. Anyway, we're going to be able to use the power rule and not do the limits at all. But before we can get to section 2.2 and using power rule and fun things like that, and a lot more that you didn't see this summer, we have to do it the limit way, as a nice little segue from the limits that made everything possible to the slopes of the tangent lines using limits to the shortcut rules. So let's get this idea solid in 2.1 so that we can get to the shortcut rules quicker. But long story short, are you allowed to use shortcut rules in section 2.1? Here we go. Who is the slope of a tangent line, aka the slope of the graph at one point, aka the instantaneous rate at a point? The derivative. A word that you have seen before and that we've used before, but that now it's time to really dig deep on, or into, I should say. The definition of the derivative is technically given by the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. However, some of you guys don't like delta x, so what are you allowed to do instead? Let h equal delta x. And then you can go ahead and just change this to be f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all over h. Here's the dealio. You guys want to see on this forever card? Forever card? We have a new one. Forever number 6, I believe. Does that sound right? Because I think our quiz was 1 through 5. We're going to have quite a few forevers this chapter, but the nice thing is some of them are short. On this forever card, on forever number 6, on any forever quiz, from the most basic one at the very beginning of the year now, to the really the end of the year that are on all the cumulative cards, and everything in between, guess what is the most common mistake that kids make on this card? What do you think? What's the most common mistake that students would make on this card. You can ponder. I'm going to rewrite it because it looks kind of gross and disgusting and it's a forever card. Any ideas? Yeah. What part of the derivative? They actually don't mess up this usually. They usually put the limit. Some people don't. You're right. Some people forgot that or forget that. The F prime. Some of you guys, and I just didn't get it. So good job, anyone who thought. This is what is most commonly forgotten. Like, oh, it's a limit formula, limit formula, limit formula, limit formula. That's even if they remember the card, limit formula. But what don't they remember? What is the limit formula? F prime of x. And I take off points if you don't write it. F prime of x equals. F prime of x equals. Now, technically, it's only if the limit exists. But if the limit exists, f prime of x is a function. He's an entire function. He's not just one slope. He's all the slopes to a graph at all the different possible x values. So in homework, when it says find f prime of x using the definition, if you know the power rule, can you double check your answers at the end? Yes, you can. But is that the way to solve it in homework? No. Will I give you credit for attempting the homework? Use the shortcut rules and not the limits? No. But can you check with the power rule if you want to? Yes. But you don't know how to do one like this yet. So don't you dare do a rule. To know. Oh, definition of derivative. Thanks for asking. Kind of like definition of continuous. Definition of derivative. If you want, you could put in parentheses limit definition. Limit definition. Because it can come like this one. Technically, if you say tissues, paper towels, front table. Sorry, you can go behind the smartboard. Definition. If they say that, that means the limit process. But the book might use actual something to remind you it's a limit in the process, or in the direction. So number 1. What do you guys like, H or delta X? You get to choose. Okay, what's the very first thing I want you to write? F X equals. Did you do it? Are you doing it? F prime of X equals. Ready, set, get a little bit ahead of me. You guys can plug it. Turns quotient. Ooh, hold on, pause. Okay, now you guys know. If you like delta X, do delta X. Buddy, this is what we're doing right now, right? What class are we in? Is it getting messy yet? Are you avoiding killing seals and puppies? I guess you wouldn't be doing either if you're not simplifying yet. Did you plug in right? Double check, double check. Why am I saying puppies and seals? What am I trying to warn you against? The puppies, you better be careful of the square. The seals, you better be careful of the distribution. Right? Did you miss the first page, Ryan? You just skip a few lines. So derivative and tangent line problem. Maybe skip like 2 lines and you get your definition of derivative. The title's up on the board too if you need it. Alright, I'm just going to bust it out. I was trying to give you a head start. You can keep going if you think you can. So okay, if I go ahead and distribute the 5 and make it 5x squared plus 10hx, or xh, either way works. You guys know how the difference quotient works. We've done this enough times last year and this year in the summer packet, right? What should cancel out? Everything without n. Can you generalize it? Everything without n h, right? Is what should cancel out. Wait a minute. Uh-oh, 7x and... Oh, there he is. 3, 3. What's left? What you got with h's? What can I do with all those h's? Factor out an h. What happens when I factor out an h? I can reduce it with the denominator, right? Those of you guys that like the power rule. Now it's time to check. Because we're down to our final answer. Whoa! How did I go from here to here? I know some of you it's super obvious, some of you it's super not. How did I go from here, the limit problem, to here? Yeah, just plug in 0, it's gone, no big deal. Okay, I factored out an h, I simplified with the bottom, so my 0 over 0, keep going, is gone. I plug in h is 0, and I get 10x minus 7. Dun, 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 dun. Whoa, power rule, people, does it work? Don't worry, we'll practice the power rule lots and lots and lots next section. But for those of you that know the power rule, what happens to the 2? Pops down. 2 times 5 is? What happens to the power? Decreases by 1. Got it. What happens to the power? Negative 7 times 1 is negative 7. What happens to the power of x? Comes down to reduced by 1. Was gone. Wait, what happens to the 3? Derivative of any constant is 0. We'll memorize it. Or you can think of 3 times x to the 0. The 0 comes down. Gone. Now, this guy, we can't use the power rule. Not without something called a chain rule, which has to do with killing bunnies. I mean, keeping bunnies alive. So, we have to use the limit definition. There's no other way that you possibly, by hand, can do this. And I said you possibly by hand, not you going to Wolfram Alpha and saying, hey, it takes derivatives. Anyway, so, f prime of x, yes, there are calculators online. Limit as h goes to 0. But that doesn't help you get any smarter or better or more capable. But it could help you check answers if you're stuck and want to make sure before class which ones you get or don't get. Let's do this together because it's a little bit tricky. Can we realize that we need a f of x plus h-ish thing and an f of x thing and an h? What are the easiest things to plug in? These two. Right? Steal f of x, put them in. Steal h, put them in, and we have the rest of it ready to go. What's missing? Yeah. F of x plus h. Does the 2 change? Nope. Does the square root change? Nope. Does the denominator change? Or the radicand? Yeah. Are we okay if we do, or if I do, 3x plus 3h minus 1? What'd I do? I did a little f of x plus h work in my head first. 2 over the square root of 3 times x plus h minus 1. I distributed my 3. 3x plus 3h minus 1. Oh, snap! What's a bummer with this one? Yeah, the denominators don't match. Uh-oh. And guess what happens when you plug in right now for any difference quotient ever, but for this one also. If I plug in h is 0, they do match. 0 over 0, keep going. But I can't combine like terms because they're not like. You guys have any ideas? conjugate. But there's fraction, conjugate. But, conjugate. Sorry. You could factor out a 2 if you want, and then do a conjugate, or just do a conjugate. What's the conjugate going to be? Am I doing the conjugate of the top or the bottom? Yeah. Conjugate says instead of A minus B, I do A. Do it. I know you don't like it, but do it. So 2 over the square root of 3x plus 3h minus 1 plus 2 over the square root of 3x. Sorry. Can you fit it in yours? 2 over the square root of 3x minus 1. Do we need some parentheses whenever we're doing conjugates to keep us honest? Most of us, yeah. If you haven't gotten ahead of me yet, I'm going to give you 30 seconds. Do what you can. I'll come behind. We'll make sure we're good. I'll come behind. We'll make sure we're good. But what would you do? Question, did that fix everything? Remember, a minus b times a plus b is going to be the same thing as a squared minus b squared. Where you could have foiled the whole thing, you would have had a positive 4 with nasty roots, and then negative nasty roots, they cancel out. You get the first squared, 2 times 2, and root times root. Second one, minus 2 times 2, and root times root. But what's the struggle? It didn't just have a square root. Doesn't it also have complex fractions? So what do we do? AJ, what's wrong? Thank you, thank you, thank you. I didn't write it, did I? Thank you, thank you, thank you. How do we get rid of complex fractions? Multiply top and bottom by? Both? Yes. Just like we always. I agree. Thanks, Ryan. Am I putting in parentheses to keep me honest? I have to take the whole thing to both. Did I lose anybody yet? Are we okay? If you're not, would you tell me? That's where the rubber meets the road, huh? Are we okay if we realize that 3x minus 1 sticks around for the first and the 3x plus 3h minus 1 sticks around for the second? Right? What do we have in the bottom? Does anybody see any problems as we're looking at this? I was hoping somebody would. Took us a little while. Anybody have a good answer for that? It took us a long time. I was hoping it would happen sooner. Thomas said when we go back to the top. What do you ask me? What do you guys think? When we multiply by a conjugate, how do we always do it? Who didn't belong? How do I know that's the case? Is my h squared going to cancel out with anybody? Why do you think I asked if anybody had any questions? What should that be? It wasn't balanced. I totally threw the whole thing off. I was like, hey, the conjugate and whatever h, let's go. What should have been down here in the bottom instead of an h squared? You got to keep it balanced. You got to multiply the top and bottom by 7. Oh my, I know. How many of you guys saw that? Why didn't you say anything? 1, 2, 3, 4, 5, 6. Oh my goodness. Killing me, Smalls. Killing me. Now pause. It's dangerous. Don't just randomly follow people, even when you trust them. Okay. Even when they're teaching. We can talk about discernment and all sorts of good stuff right about now, but we'll move on. What needs to change? Pause. Some of you on a test would be frustrated right about now and just be like, I'm just going to erase the whole thing, and then you run out of time, and I give you a 0 on that problem. Pause. How do we strategically change our mistake? Thomas. Take out the h squared. Good. Put h on the outside. Good. And have your 2 over square root of 3x plus 3h minus 1. I just need to change my h squared. Everything else was fine. Just because you don't like something, should you just erase it? Toss it out? No. Stick around and try to fix it. There's a life lesson to that one too. Just because something gets hard doesn't mean you throw the whole thing out. So then what else changes? This guy. It's still just an h, but who's along for the ride with this whole bleh? That guy. That whole bleh. Thanks, Ryan. I agree. Whoo! There we go. Having fun yet? Me either. Start talking. Ask the basketball girls. I heard the other day they had a silent practice. The coach made them not talk the entire practice. Actually, the assistant coach. Every time someone talked, they ran. But why? Why would a coach do that for a basketball team when the coach is usually yelling, talk, 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 talk? Why do they have a silent practice? To see what happens when you don't talk and how you can't do it well. So guess what? Our silent class didn't work well. So talk. Okay, anyway, coming back. I should be a coach. Get a whistle out. Yes, I should get a whistle. That'd be so fun. All right, coming back. I had it when I taught PE. It's been a while. Limit as h goes to 0. Don't miss going home with all like the black thingies in my shoes every day, though. Huh? Well, I mean, at this point, we kind of have it understood. I was rewriting it for a while just to make a point that you guys don't forget. What happens when we do the 12x minus 4 minus 12x minus 12h plus 4? I didn't write the x, thank you. The 12x minus the 12x cancels, the 4 minus the 4 cancels, and I end up with a negative 12h. What's going to happen to the whole blah down there? Everything's going to be there but the h is going to cancel. 3x plus 3h minus 1 times 3x plus 1 times, hey, what's 2 plus, oh, no, I can't do that. All right, 2 over, they're still not like terms. Such a mighty sigh. What can I do with my h's? Yeah, so that all canceled out. Now I'm down to this. I can reduce the h. Totally legal. And can I plug in once the h is gone in the denominator? I hope so. So what do we got? On the top we have negative 12, yeah? I'm plugging in, so I'm not writing my limit all over. That becomes a 0. 3x minus 1 squared. Good. And 4, because that h is going to make them now like terms. I can go ahead and combine because there's a plus, so 4 over the square root of 3x minus 1. Oh, wow. Hold on, I think I can reduce this thing, right? I think I can reduce it to be, doesn't the 12 and the 4 reduce to 3 and 1? And can't I rewrite this to be negative 3 over 3x minus 1 squared all over 3x minus 1 to the 1/2? What can I do if I have like bases being divided with their powers? Not set them equal. Subtract. Maybe you said that and I heard it wrong. You can subtract their powers. X to the a over x to the b is x to the a minus b. End up with negative 3 all over 3x minus 1 to the 3/2, which is the same thing as negative 3 to the negative 3/2. And maybe, just maybe, a couple of you could see how, oh, sorry, I went too far. Something like this, even though I said you can't use the power rule yet without learning something called the chain rule, maybe just a few of you could see where an answer like this could kind of come from. If our beginning problem was, what was our beginning problem? 2 over? No, 1 over? Minus 1, I think, right? Which is the same thing as does the power come down and have a negative? And do you take away 1 from the power, minus 2 over 2? But then where did that come from? I can explain the negative with him coming down, the 2's canceling, there being a negative. I can explain the negative 3/2 with subtracting 1, but there's this extra little 3 piece. Hence why we can't do this entirely by ourselves first. But if some of you look at chain rule and realize that if you have a composition of functions, you take the derivative of the outside, keeping the inside, and then times u prime, which would be the derivative of the inside, which is 3, maybe, just maybe, you can learn the shortcut rule early. Kiddos, this section, though, isn't just doing limit definitions. This section isn't just doing limit definitions. This is a really good one. Let's save this for Monday bell work. Let's go to this instead. Let's get a few more notes down, so that way you guys can do a little bit more homework. Look at the calendar real fast. Good. Homework number 7, which is section 2.1. It's not going to be due until next week. We'll say next Tuesday for right now, but it might be next Wednesday. We'll say next Tuesday for right now. It might be next Wednesday. What do you guys notice about what's different on this page as far as like the equals? It's f prime of a instead of x. Wait, what did we see in last chapter whenever there was like a's and b's and c's? What were they talking about? You were trying to find a, find b, find c. Weren't they just particular points? Oh, hey, it says that. Using the definition of the derivative at x equals, wait a minute, c, and then I put a, that's confusing. Can you guys change these little c's to a's for me? You can make them c's, you can make them a's. As we saw in last chapter, they can use a's, b's, c's, k's. K's are always y values though, but yeah, let's make them so everything matches. So if we're going at x equals a, trying to find the derivative at a particular point, x equals a, then we're going to be finding f prime of a. There are a couple different ways this can happen. Here's one. You guys okay if I just use h to make life easy? The limit as h approaches 0. Wait, that's the beginning of the one we just talked about, right? But how does the rest of the definition of derivative go? The limit as h approaches, f prime of x, the old one, equals the limit as h approaches 0 of, but who's in the x spot? So instead of x plus h, it's going to be a plus h. Minus, what's the rest? F of x is going to become f of a. Good, 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 all over. Okay, that's one way. That's one way. And if you plug into this guy, if you've done it correctly, it's going to be 0 over 0, keep going, right? If you do it correctly, it's going to be 0 over 0, keep going. However, there is another way. This is going to be an or. The other way doesn't have h approaching 0, it has x approaching a. And instead of having like h, which is delta x, actually showing the delta x of x minus a, the subtraction of two x's, which we could put the subtraction of their y's as well. This is literally just a y2 minus y1 over x2 minus x1, where x2 is just x and x1 is just a. And check it. If you plug into this guy, won't it be f of a minus f of a over a minus a? Wouldn't that also be 0 over 0, keep going? So both of them are 0 over 0, keep going. Both of them denote the exact same thing of, hey, we're just taking the derivative and plugging in a. So I want you guys to write on this side, f prime of a is f prime of x such that x equals a. F prime of a is f prime of x such that x equals a. And I'm just building you up to when we do have the shortcut rules and we'll be able to solve this in a faster, quicker, more efficient way. Or sometimes even in a possible way, whereas the other way would be impossible. But f prime of a, what does that literally mean? That means f prime of x, the derivative, plugging in a. And so think, it's the definition of the derivative, instead of x plugging in a, or, well, this one's a little bit harder, but change in y over change in x, without any like shortcut notations, without any h's. And if they were to ever ask us to find the equation of the tangent line, because the derivative is answering the slope of the tangent line. Wait, slope, hold on. What equation of a line did I say last year was going to be super, 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 super important in calculus? Y minus y1 equals m times x minus x1. So I want you guys to put that. So that's ultimately what this is. Y minus y1 equals m times x minus x1. But now we have things like, the m, the slope of a tangent line, is a little more complicated. So this is the basic equation. Y minus y1 equals m times x minus x1. But in your head, you have to understand, well, the x1 is the a, just like it was up here. The x1 is a. The y1 will be his y, which is f of a. And the slope will be his derivative, which is f prime of a. We need a point. We need an x. We need a y. Who's the x? A. Who's the y? A is y. Oh, f of a. Who's the slope? The derivative at a. Okay, f prime of a. Whew, there's a lot of stuff on this page. It's pretty stinking important. Which is why he's forever card number 7. Now, guys, this is a card where I would not ask you to state the entire card. There's a lot of different information. But I could do something like, give me an alternate form of a derivative, or f prime of a equals, you give me something, some definition, one of them that's equivalent. Or I could say, how do you find a tangent line? I would ask you the pieces of this card. I wouldn't ask you the entire. The entire cards are things like theorems and definitions. This is forever number 7. Janelle, just with regards to your other question, titling it, you could say problem-solving clues, but does that necessarily like attach you to the card? I think this one for a title, I would do problem-solving clues and like bullet points, and I would do alternate. I would use that as part of the title, alternate forms of derivative definition. And then I would do tangent line equation. That's what I would put. I would do problem-solving clues, bullet point, and one of them would be alternate forms, and the other one, alternate forms of definition of derivative. Then the other bullet point would be tangent line equation. Huh? One card, 2 bullet points. Yeah, well, kind of like, you remember I guys did the, what was it, the pre-cal card? And you had the unit circle, and then, like, it would have been helpful if you had put on the front of that card unit circle and trig properties so that you could fill them in. That's kind of what's going on here also. Okay, kiddos, what are we going to do on Monday? You're like, what else is there to the section? We're going to practice. And see some other notations. Talk about continuity a little bit. But as far as the math goes, we basically have an idea from your summer packet of what the math is. We just need to talk about some more notation-y things. You guys can get out of here. Happy Friday. Happy weekend. Oh, leave your reflections if you have them close. Give them to me on your way out. Oh, see